topic about AI in smart greenhouses, enhancing crop monitoring and environmental control. Association Professor Dr. MD Associate Professor Dr. MD Parvez Islam is attending online by Zoom meeting. And this session will be led by our moderator, Dr. Rizky Maftuho. We will start this session by introducing the moderator along with her academic and professional journey. Dr. Rizky Maftuho is a lecturer at Universitas Gadjah Mada with expertise in soil science and sustainable agriculture. She holds a doctoral degree from Boku University, Vienna, where she focused on restoring post-mining soils using local amendments. Dr. Rizky has led international research projects funded by Asia Uninet and Erasmus+, and her work has been presented at prestigious scientific forums, including the European Geoscience Union, and her recent publication highlight advancement in soil regeneration, heavy metal remediation, and tropical agroecosystem. Without further ado, please welcome our moderator in this session, Dr. Rizky Maftuho. The time is yours.
Oke. Assalamualaikum warahmatullahi wabarakatuh. Good
Good
morning,
morning,
everybody.
everybody.
Okay. Good morning, everybody, especially for Associate Professor MD Parvez Islam. Good morning. I'm happy to see you here, although it is online, but I hope that we can have a valuable discussion about the AI in agriculture system. Okay, before we start the lecture, first I would like introduce our speaker. Yeah, my name is Rizky Maftuah, or you can call me Kiki. I'm a lecturer from the Department of Agricultural and Biosystem Engineering, Universitas Gadjah Mada. And now I will be your moderator in this session. Before we start the session, I will introduce our speaker. We are honored to have here Associate Professor MD Parvez Islam, PhD, with us. Dr. Parvez Islam is an associate professor at Ehime University at the Faculty of Agriculture that located in Matsuyama, Japan. He was holding a PhD in biomechanical systems from the Ehime University. At this moment, Dr. Parvez is an associate professor in the Graduate School of Agriculture, Ehime University. And he has many expertise, especially about the plant factory research. And Dr. Parvez also is a biomechanical specialist with expertise in artificial neural network modeling and simulation. In particular, his current research interests include for low-cost cooling system and finite element method analysis. He also has numerous publications and over 4,000 citations. Therefore, Dr. Parvez contributes significantly in advancing intelligent system in agriculture. Yeah, in the slide, you can also see some of the background, especially the research history for Dr. Parvez Islam. Okay, let's continue. I would like to invite Associate Professor Dr. Parvez Islam from the Ehime University to join us and begin the presentation on artificial intelligence applications for advancing the agri-food industry. We have for the presentation we have around time around 60 minutes, and then we will continue with the discussion. Now time is yours. Please welcome Dr. Parvez Islam.
Thank you, Dr. Rizky Mahtuka. Uh, Good afternoon. I hope that today I will try to explain about latest research on artificial intelligence in agriculture. So I think that you can listen me clearly. Yes, there is no problem. Okay, the voice is okay. Ah, thank
Okay.
you. So let's start my lecture. I want to share my slide. Maybe it's better screen. And then okay. Let's already you know about myself that I am already associate professor of the Ehime University, and also most of my study my how can I say in the Ehime University I mostly graduate school of agriculture, and I also attend the United Graduate of School of Agriculture Science. This is for masters and PhD students, and others is plant factory system, plant factory information system, the research and development center, and data science center. So a lot of activities different types. Okay, let's start from the background. Why we want to do research in artificial intelligence, and why Japan is trying to focus on this in this moment. So you know that in general, everyone we have some idea that the world temperature it's increasing. So it's increasing from the mean average temperature. You can see
Uh,
the hello.
Sorry for interrupting.
Yes, yes,
Can you uh, move
yeah.
to a slideshow for your presentation with slideshow?
Oh, it's not slideshow. Okay, okay, okay. Oh, sorry.
Yeah,
It's okay.
yeah, yeah.
Okay.
Thank you.
Okay. So you can see that this is the how can I say the increasing the trend mean average temperature. So from 2000, the world mean average temperature is increasing, and now 2020. So it's more than 0.5 degree, and the increasing rate from 2020 to 2030 is more than 0.5. So maybe you already see that many places have too much rainfall or shortage of water. In Japan, we have particularly problem in the summer. The summer temperature is increasing. Even today, in some portion of the Japan, the average temperature is 39 degree around, and the winter time also too cold, and sometimes how can say the too much snowfall or too much rainfall. So the dynamic changing, the environment changes dynamically. So existing control system by existing way of cultivation is not sustainable. We must need to adapt with the changing environment. So this is the one of the reason why we want to focus the automation of the agriculture with the help of artificial intelligence. The another reason in this graph you can see the in the case of Japan, the population decreasing. Mm. So this graph is so that 1961 to 2021. So it certainly increase and then decreasing. And now the trend is that 90% agricultural farmers, the mean average age, they are more than 80 years old. So they are aging people involved in the agriculture. At the same time, land use pattern is decreasing. Mm. Population decreasing, also land use pattern decreasing, yield per hectare is increased, but overall production is decreasing because we less people is involved with the agriculture. So the young generation they don't want to do agriculture activity because it's hard work and the very challenging. So we must need to make a solution where young people involved with the agriculture, and they feel how can say with the help of artificial intelligence or some supporting system, they feel comfort to start agriculture startup, agriculture business. So like marketing is and also increasing production and cope with the environmental change, we must need to focus new types of cultivation methods, new kinds of control system, and also supporting mechanism. Here you can see the what's happened when the temperature increases. So previously, actually, we don't take care, we don't think about what the surrounding environment impact on some particular plants. Hmm. But when you cultivate, how can say, in the plant factory or some like how can say, when the cultivation cost is high, then every plant has value. If you lose one plant due to the stress or something, you will lose your money. So we must take care all plants and we must find out where the stress occur and how fast we can detect or recognize the stress, then we can solve it. Here you can see the if you use thermal imaging camera, the tomato cultivation. So all plants are okay, but this blue color is that it has a strong stress condition. Hmm. So we must need to find out this condition in the environment. Here, once you have high temperature stress or low temperature stress, after that the leaf damage and is stop photosynthesis and other things is cause the spread of disease. So disease started spreading over the plants and your production will be lost. Here you can see that another problem is that color. So how when you buy any fruits or vegetables, first we see the color, then we can see the shape of the your vegetables or fruits. Then the how can say how much it hard or soft or other things and smell also. So color is the very important parameter. But you know that for tomato cultivation, from flowering stage to harvest, uh, it take how can say 1 month, and the total temperature to 420 degrees centigrade is required. So if you have this temperature, the tomato will be beautiful color. I mean attractive color, red color and other things. But if the temperature is less, then tomato will be like pink color or other discolor. So the value will be decreased and the taste will also different. So in the summer, if temperature like today 39 degree, so within 30 days the temperature will be more than 420 degree. So early ripen or early coloring in the summer stage. So fruits not matured but color would be red. But in the winter time it's just opposite. Fruits matured but color is not red. Uh, it's like pink color. So both is the problem for farmers for selling and also taste. So another thing is that in the summertime, these types of problem occurred in the greenhouse or plant factory. So in the summer cultivation, more than 60% tomato, it has like crack problem. Too much, how can say, or temperature, too much hot temperature, and also ion deposit and other disease. You can see the different types of summer and winter. And this is also in the case of eggplant vegetables. The left side it has high value, the middle is medium value, but the right side it has no value because of the color. But inside is okay, you can eat it, no problem. But the color is discolor, and this is the high temperature due to the disorder. So we must ensure control the color. We must control the environment to ensure the quality of the fruits and vegetables. So for this purpose, Japan decided to introduce like new generation agriculture based on information, data science, data. We will collect lot of data like imaging data, sensing data, and marketing data, and then we will analyze those data and we support farmers to take like how can they say they can control the watering or control the environment, change the environmental parameter and everything, but all of this like semi-automatic or manual. So farmers leave the get the instruction and then they change the parameter. Hmm. So for automation, we need like real-time monitoring and real-time sensing system. Hmm. So this is like next goal out. So this is the experiment where we have done most of them. This is the plant factory. So each plant factory, this mostly produce tomato. So 1 square meter, in the area of 1 square meter, we can get more than 70 kilogram per year, around 70 kilogram. So we can get lot of tomato in 1 square meter, but we must need lot of energy input. Uh, because now the temperature is changing. It is too cold or too hot. So you must need to cool in the summer, but in the winter you must need to warm or hot inside the environment. So this is the very expensive now. In the electricity cost is rising, and also different the how can say the salary and other costs also increasing. So it's very difficult. So this is another plant factory where we mostly use for experimental, the new kinds of cultivation system, or for how can say the marketing of the tomato, new varieties or something. So here you can see that it's not matter, it's plant factory, greenhouse, or open field cultivation. The cultivation system is a lot of activity. So first you have physical parameter. It's like production area, which types of greenhouse on plant factory you will use, which types of soil you have, the height of the land, the different types of the lighting condition, a lot of parameter. Hmm. Then we have environmental parameter. Here is like solar radiation, because it is important for photosynthesis, the light duration, huh, the CO2 level, the temperature, and different types of environmental parameter. Then irrigation parameter. So how much water, how much fertilizer, how much media, which media you will use, the pH value, TDS value, a lot of parameter you need to know. Then of course, after if you manage this physical parameter, environmental parameter, and irrigation, then your plant will have growth. How you can measure the growth? You must have some kinds of sensing device, camera, or other things, and you must measure the photosynthesis parameter, the greening index, chlorophyll content, leaf parameter, and other things. And then you have reproductive data. It means that flowering, fruiting stage, and different types of this stage. So the fruit timing, the harvesting timing, lot of things. And after that, the yield. The yields mean that the quality, the sweetness, like Briggs value, the yield quantity, the color parameter, and others. And after that, marketing. So if you have we have all data in this stage, then and if we optimize these parameters, then we can reduce the number of parameters, and we can get the output, good yield, and good marketing condition. So until now, in the most greenhouse or plant factory use on-off actuation, just switch on-off. So most of the farmers still use, because it's the most cheapest. So you just need, when you need water, you just on, when you don't need, you just off. Then other complexity, then if too much hot, too much cold, or if you have lack of CO2, if you have less light, if you have like too much radiation, you need to use curtain. Then different types of control system. The fuzzy logic based, artificial neural net, genetic algorithm, and then latest is artificial intelligence algorithm. And beside this, we have some expert system and model predictive control. So predetermined parameter. So this also used for controlling. But artificial intelligence is the latest, and it will be future for the future system. So, okay, now in this moment, we are discuss about the background and the problem associated with the cultivation inside the greenhouse or plant factory due to the environmental factor and others. So if we solve all this problem, we must need data. So how we collect data? So you can see that we have like multispectral camera, thermal imaging camera. Then we use drone, also like fixed platform, and the open and greenhouse. This is the how we collect the data set from the field and from the greenhouse. So one of the things you can see that two types of data collection method, direct and indirect. Direct method is non-destructive, I can say. Hmm. It's like thermal imaging camera, RGB camera, multispectral camera. But indirect method is sensing device like quantum light sensor, uh, like EC, photovoltaic, no, pH sensor, CO2 sensor, and different. And we also have like dendrometer or other sensing device to monitor the water movement. How much irrigation, after irrigation, how much water plant absorb. We can monitor this using dendrometer or other some kind of sensor. So here you can see that in the greenhouse, if you monitor 24 hours a day using RGB camera or thermal imaging camera, you can see the growth and daytime response. So every day is photosynthesis. It's absorb energy, create fruit, and at night is grow. So this is the few days data. So we can see the plant is growing every night. So we can monitor which days it has stress and what's impact on the night. If it is too hot or too cold, then at night it will have no growth. So this is the one of the way which you can monitor the plant response. Then okay, RGB camera, it has some advantage or disadvantage. Advantage is clear. You can image, see the visually. But at night, you cannot take the image without light. So light also sometimes causes stress. So if you don't use light, we can use thermal imaging camera. The left side is thermal camera. The right side is RGB camera. So same thing. So we can monitor day-night temperature. But thermal camera has the problem, the noise, the background noise. Because if background noise and leaf temperature noise is the same level, then it is difficult to distinguish which is background, which is leaf. So in that case, artificial intelligence can support us. So we just delete the background and we can just keep the leaf area and we can see the leaf temperature range or growth. So this is the way we can do it. So this is the, how can I say, the thermal image. I show you the drone image. RGB based drone image is good, but it has some lot of problem that due to the height, sometimes it's difficult to feel the separate the weed and vegetable. So if both is the green, so it's very difficult to separate. But in this case, it's cabbage, and you can see the distinguish. We can distinguish the weed and cabbage. But in the case of lettuce, it's very difficult because both are the same color almost, green, light green color. So this is the way in which we can measure the data, and then we can separate background and then predict. So if you use all of this separation of manually, it's impossible. So we must need data, then train network, and then separate background, and then we can calculate what you want to do. So I told you about the RGB and thermal camera. Why RGB image is necessary? Maybe it is some kinds of question. So this is very common sense because RGB is what we see the color, daytime color. It's RGB. So it's 400 to 700 nanometer, the range. So in this range, photosynthesis also occurs. So plant use this range 400 to 900 nanometer for photosynthesis. Is convert CO2 energy and others for producing energy, food, and then grow. So if you know the photosynthesis what is, then you can this is a very important because plant use photosynthesis RGB image for. So here you can see that for 400 to 700. But in some cases 710 or 850 also somehow important parameter because it's like some kinds of morphological development is required in the nature. But for 400 to 900 meter is enough to get the response, to measure the response of the plants. So here you can see that what's happened if you use only R or red color or blue color or green color. So the red or blue spectrum, if we cultivate lettuce, the lettuce growth is taller. It's not like shape. It's not no round shape. It's like it lost the shape. Only leaf is too big or something. Irregular shape we call it. But if we use RGB, three spectrum together, the lettuce become round shape. It's grow well. So this is the reason RGB has very good impact on plants, and we also use RGB color image for plant response monitoring. So here is the one example, like how can I say, artificial intelligence based plant tomato plant monitoring system. Is we developed a like I say, monitoring system only in this moment with tomato. So from seedling to cultivation. So all operation we can monitor. During seedling stage, after the germination, we monitor which seedling is healthy, hmm, and which we use for further plantation. Hmm. This is good for seedling. Like how can I say, there is a big company who produce only seedlings, and they sell it. So initially they manually check the quality of the seedling, but we replace human with artificial intelligence. So because of the lack of manpower in Japan, so it can more efficiently monitoring the seedling quality and uh, supply the farmer good quality seedling. Then see, after the seedling, we must monitor the plant growth. I told you that excessive heat or cold cause the leaf damage and then is disease spreading. So we must monitor the leaf condition, healthy condition. So early monitoring, early detection of the leaf disease is very important in the greenhouse and or plant factory or even in the open field, anywhere. The farmers owns it. So we also develop this method. Then how can I say, you have the flower, you have the bud and then flower, and then you can calculate how much flower it will become fruits. Hmm. Because of the bite mark, the bee, we use bee for pollination. So when bee bite the flower, it has some like spot or something. So we can calculate the number of flowers. So this flower is possibility to pollinate and it will become fruits. So farmers have early like idea how much fruits it can get. And then of course during fruit the stage, growth stage, the color, shape, the growth parameter, the area of the fruit growth area, we can measure, and then coloring, and then after that harvesting time. So which color we want for harvesting? If we want like more storage time, if we need to keep storage time longer, you need to early harvest. Or if you want to sell it immediately, you need like deeper color. So depend on this, we need to optimize the color level. So which color we should select. And also the farm in the plant factory or greenhouse, the worker who works there. So we also need to monitoring their activity because it's too hot condition in the plant factory or greenhouse, 45, 50 degree. Sometimes they have problem with the heat stroke and others. And also slow working condition. Sometimes feel tired and they don't work and slowly and talking or other activity. So we can monitoring their activity, how they work and others. So this is the our mechanism. So we have a lot of challenges during this process, like disease first. It's very difficult to detect, to recognize in the early stage because disease occurred in a small space, small leaf, a small pixel area of the leaf. So you must need to manually find out and then take pictures and then train. Then another problem is that data collection. So if you have lack of knowledge how to set up the camera, then using professional camera is difficult to take good quality of image. So why we collect different types of camera and also use cellular phone for taking the image. So the variety of the media, source of the data collection. So, and then environmental condition. The leaf color and fruit color is the same. So the dark condition also difficult to distinguish the color. So we must think about that. And of course, the manual annotation. After you have lot of data, so farmers, how can I say, the annotator, they made mistake when they use lot of data for annotation. So human error there is also. So we must think about the data variety, data pattern. Here, just example, here is like 32,000 images. So if you see that homogeneity, skewness, or standard deviation of the data set, so there is a lot of wave. It means that it has lot of pattern. The more pattern, you have the artificial intelligence learn more better. Your network will be more robust for real-time detection or classification or recognition. So this is the 32,000 images, and you can see the lot of pattern. Okay, in this moment, I just try to minimize the data collection and data quality. So next, the main problem we have that which types of algorithm we use. Two types I can say. Just we can download, then train and end user use it. But in this case, you have problem. If you commercialize it, you must have license. Without license, you cannot use it. Hmm. The main another problem is that there is a freedom of use. It means that if you can download the network, but it's not suitable for your data. So you can try to optimize different training parameter of other things, but you have no access the algorithm. So you cannot modify in the algorithm. So sometimes in the real time, it's not working well as reported or published a lot of papers, but in the real time, if you use it, you can see the difference. Hmm. So I mostly prefer like develop your own network and compromise or adapt it to your own data set. Hmm. So you can use for complex data set and it will be suitable for real-time operation. So you can also optimize your type parameter optimization, training parameter, and also hyperparameter optimization. You have freedom. And final, you don't have license on the algorithm. Yeah, if you want to like how can I say example, if you developed a algorithm in MATLAB, you have freedom to use algorithm, but for environment, you must have license, like MATLAB license. But if you convert your algorithm to Python, like PyTorch or TensorFlow, then you have freedom to use everything. So this is the like how you want to use and which environment you want to use, depend on. Okay, this is the algorithm. So now let's think about some thinking about machine learning or artificial intelligence. Actually, artificial intelligence is the combination of machine learning and deep learning. Right? So you can see machine learning and deep learning is two different concepts. Machine learning is mostly learned data. I said it mechanically. It's not mechanical. It's mathematical. Hmm. It's mathematical calculation, most linear relationship. Deep learning is learn and memorize the complex pattern. So the artificial intelligence new types in generation we have merged together in machine learning and deep learning, and then it's become artificial intelligence. So if you only use machine learning and you can say it's artificial intelligence or this is artificial intelligence, it's not 100% accurate. But for commercialization, many company, many people use artificial intelligence, although they use only machine learning. So machine, if you merge machine learning and deep learning, then it can almost like a human. Huh? it can predict, it can learn, and it can improve further. So here is an example of the algorithm, uh, CNN-based algorithm, convolution neural network, I call it. So we use for image processing convolution and plus neural network. So together is convolution neural network. So here is an example of my developed CNN. So it's like how can I say, it's process the image and then predict disease or other things. So how it's calculated, how is predict, how is understand that this is human, this is disease, or this is fruits. Okay, this is the example. So I told you that we use RGB images. It's mean red, green, and blue. So here you can see that this image, and here is the different point we can see the pixel value of the image, the RGB. So you can see the value is different, R, G, and B. It has different value based on the place. So artificial intelligence memorize this pattern and then predict. So how it's memorized? Okay, let's I to explain you the how convolutional neural network works. So you can see the RGB. This is the pixel value. It's very like simple 1010. Then we have filter. Filter also pixel 1 minus 1 minus 1. So if you multiply, you can see the new value is there. So here is 1, the pixel value is 1, 0, 0, 0, 1, 0. Okay, more again. 1, 0, 0, 0, 1, 0, 0, 0, 1. This is the pixel value of the image. And this is the filter value of the image. If you multiply, we get new value 3. Then next we go minus 1, then minus 3, minus 1. So in this way, the filter is move over the image and is create new images. So the more filter, the more new images it will create. So this new image we call in artificial in our field feature map, not image, a feature map. It contains some kinds of information which can distinguish the class or your target class. So it has some pattern. So the more pattern you will increase, there is more possibility to classify or detect. So here is on filter. Then if you use another filter, like filter 2, then new value. You can see the different value, different parent. But image the same, but filter changes, the value is also changes. So we use 20 filter, 30 filters, 100 filters, 500 filters, lot of filters we use for distinguish this class. So there is no universal rules that if you use 60 filters or 1,000 filters, you will get the accurate result, more better result. So we must optimize based on your network architecture. This is feature there. Then one more thing we use pooling. Pooling, we have two types mostly used, maximum pooling and average pooling. So maximum pooling, you understand the maximum value. So we have, I show you that the pixel value here, you can see the 3 into 3. So minus 4, 5, 3. So you can see the 9, 4, 3, 7. So it's generate the new value from the pixel value. It's not calculate any new thing. It's just take the maximum value from the filter. In this case, the feature map decrease, size of the feature map decrease, but it's maintain the maximum value. The average value, you understand that the pixel we can average and then we use. So if you use maximum value, the output will look like that. If you use average pooling, the output will be like that. So maximum value, it has good age, but average pooling, it's more realistic picture. So this is also no universal rule, which pooling you should use. Sometimes you use average pooling or maximum pooling or together. But the advantage of the pooling is that reducing the time, because you see that one filter is move over the images and it create new feature. So if you have 64 filters, is 64 times you move, a lot of times it move. But in the maximum pooling, is that move and is that take the maximum value. The calculation time is less. So to optimize the how can I say, training time, we use CNN and maximum pool. So here is just an example. So here if you use like this the picture, pixel, and then filter. So the filter is moving from left to right, right to left, or different condition. And once you have done this operation, then each time, like in the case of bird, you conclude the CNN, convolution. The filter move and move, and different area, the mouth, eye, and the leg, downside leg, and it's separate, and it's memorize this part. And then when you use your own data, is memorize data is compare and see, this is the output. So it say that bird or cat or other things. So how can I say, the memorizing is almost like human neural network. So why we call it convolution plus neural, both together is become convolution neural network. So convolution is only create new features, but neuron is memorize the pattern and then predict. So you have algorithm, you have data, you train your data with the using convolution neural network, max pooling and others. But how can I say, why people start using convolution neural network everywhere now? Because we see that convolution neural network in some cases overcome the human. So here is the example. You can see that 2010 to 2012, the how can I say, machine learning algorithm in that time is how can I, improved too fast, and it's a lot of methods and development machine learning algorithm. So, but machine learning algorithm is achieved 16.4% accuracy. So it's a lot of mistake. The mistake rate is 16.4, I mean. Then 2012, the era of convolution neural net started. And 2015 around, it's overcome the human because there is a like image net data set, 1 million data set. So 1 million data set we train network, and also human memorize this data set. And then when they predict 5%, more than 5% mistake rate. So they mistake 5%. But network, the Microsoft developed a network ResNet, its mistake rate is less, 3.5%. So it's overcome the human. So okay, is that case we can overcome the human in some area like mistake rate. But after all, human is always has lot of advantage. I don't want to say that, but within like data set, sometimes it's difficult to memorize, not forget, but memorize in time due to the brain activity. You can think lot of things. You cannot concentrate with your target, But and how can I say, computer, if you train it, it's only concentrate on this matter. So it has no other noise. So it's perfectly predict. So this is the one of the reason to win over human. But this is the benchmark of this. So now everyone, when we develop our own network, we also train with this 1 million data set and compare how much accuracy we have. If it's over pass the human, then we can propose that this is a good network. So here is the example of such kinds of available network. You can say that Google developed exception, University of Oxford, BGG, Microsoft ResNet 50, 100, and other variation. Again, Google, Inception, then Cornell University, Tsinghua, and Facebook, DenseNet, Google MobileNet, Inception 3, and I develop another network for disease detection, other purpose. Just compare the performance. So here you can see the depth of the network is mean how many times, how many layers it has. I have in some 700 or 824, but it has less accuracy than developed by me. So this is not that said I am the best. It's not that matter. But the main thing is that we compare these types of data and we can say, my network is suitable for a practical use. This is the example. So here you can see how artificial intelligence the separate the data set. The left side you can see the lot of data is merged together. It's very difficult to distinguish the class. Then convolution started, and in the final convolution it can separate, but it still had some overlapping. But after softmax activation function, the output we can see this precisely, almost precisely detect the all classes and separate and predict. Now, this is the most strong argument to use artificial intelligence or convolutional network-based network for classification, disease detection, or other purpose. So here you can see that we can see the where is the mistake or how network predict the particular target object or classes. So in the case of like healthy or others, there is some white spot, it's water droplet. In that case, you can see that it's mistake somehow, is healthy, but it's nutrient deficiency is said because of this water droplet. So in the other case, here you can see this downside, disease affected area, but it's perfectly predict that this is the disease area despite the daylight, which is also white color. So it can predict. So this is where we can see the lack of the mistake, where this can mistake and how we can overcome. So we must overcome, we add more data set with that relevant class and improve the accuracy. And yes, this is the another thing. The after develop your network, you can see the how efficient it is, how much distance you need to predict, like target area to your camera, 1 meter, 50 centimeter, how much area, how many far or distance. So this is the recognized efficiency based on distance we measure. In plant factory, we have 60 centimeter between the row. So we use 60 centimeter as a like standard, but in the outside environment you might use depend on types of target. If it's too small, you need to near. If it's big size, then 1 meter is enough maybe. So here is the example in the real time how network predict. I think that you can see the video. So here is this tomato plant. It has nutrient deficiency and also some kinds of uh, how can I say powdery mild disease, this fungal disease. So it can predict the neutron and fungal disease. So why is the leaf contain both types of symptom? Then it can say that most accurate nutrient deficiency and then maybe powder deficiency or other disease which occur. So this is the how can I say the image classification. So in this case, we don't precisely predict. We just overall we can see and predict. This area has disease, this area has not disease, or this area are healthy, and others. So I think that you can see the output. Right? So the powder mild, this is the disease area. So you can see the leaf also contain nutrient deficiency. The between nutrient deficiency and powder mild, it has prediction. So another thing I told you that we need to monitor the human activity in the greenhouse. So here is the example of the human activity, the movement of the human activity. We can monitor, is he in good health or is his health like too much stress or he carry too much heavy some things or he has problem with the heat stroke or other things, how he is working efficiency, we can monitor. So you can see the this is the way which we take care of the plants, the crop management practice. So you must need to move, you must need to up and down and other things. So we can check the flowering condition, we can cut the leaves, or disease we can monitor and other things. So this is the way we take care of the plants. So this is why from 1 square meter we can produce more than around 70 kilogram per year. Too much yield. And then this is the like example how we can monitor the grow activity of the worker. Here, due to privacy, I cannot show the face, so we change the image. And then harvesting, after harvest, you need to separate the, how can I say, marketing for marketing strategy. Immediately sell or you need to store few days. So the red color, you need to immediately sell. But little bit pink color, others you need to separate. So here in the field condition, you can separate the immediate sale and or you need to wait a few days after the harvest. So this is the uh, detection and then counting the number of fruits. So left side, I will show you that flowering, bud, the green condition of the fruit growing stage. The right side, you can see that only tomato green and harvesting and other things. So this is two types of environmental condition with noisy environment. You can see the background is different and the, how can I say, the variety of the tomato also different. So we developed a network which can predict not only depend on variety or environment, it can predict anywhere, any places. So the robustness of the network we demonstrated here. So left side, let's see. So it's also check how much fast you move and how much it's recognizing speed. So if it's like take some time for recognize, the new network is not good. So it must immediately recognize. So if you use like VR glass, then you can easily see the which things happen with your plants and when you can harvest and other things you can get the just. So this is the efficiency test or something. So when we develop algorithm, when we train it, and after that we went to the field and check it, the live demonstration, and then we can confirm, my network is enough for like deployment or we need to maybe more data for further improvement or like that. Even camera blur, but it can predict the flower or something. Sorry. Sorry. So this is the distance, how far it can predict. You see the round shape is maybe sometimes it will cause the mistake for artificial intelligence because it's not this feel that this is tomato or not. Because tomato also round, the tag of the tomato also round. So you must precisely detect the tomato and other things. So okay. This is the then another types. Okay, let's see the right side. Same network we use, but this is a different condition. So each color has different class, like something is growing, something ready to harvest, something like you need to, like there is disorder or something, flowering stage or different stage. So here you can see the background. Some people, students are no, collecting data set and others. So this is so in our plant factory we cultivated the plant by ourselves. Students involved to cultivate the plants and then collect data and then analysis. So there, but one student not everything. Someone involved with the cultivation, someone will with the post harvest, or someone involved with the like some parameter. So this is the different things we are doing. No. Okay. So next, I'm going to show you the some thermal image. Still now I explain the RGB, but now I will try to explain the thermal image. Here you can see the leaf, but I told you that when the temperature, the background and leaf temperature is almost same, then it's very distinguished to separate manually. So here I am trying to my best to separate this manually, but you can see that after separation, the we can make a like temperature range, the minimum maximum range. So 27 degree, 33 degree, 26 degree, 30 degree. So total pixel area of this 14,000. So this area, how much area is 27 degree? You can say 20% area is the 27 degree. The 32% area temperature is 33 degree. 26% 4% area is 26. And 40% area is 30. So for plant photosynthesis, the best temperature range is 25, around 26. More than that, it will have high temperature stress. More than less, less temperature also have low temperature stress. So you can say that 26 or 27 is very near 20% and 24% area is favorable, but more than 40% area is not favorable. It's more than 30 degrees centigrade temperature. 70% area, I can say. So this condition is very stress. We must monitor and we must like cover like some kinds of curtain, fogging, spraying water or other things we need to do. In the winter time, also same thing. The for plants, favorable temperature is 25 degrees for photosynthesis. But here you can see 21, 22, it's near the 25, 18, 20. So in the winter is low temperatures. So you can, but if you separate every image by manual hand, then it will take a lot of time. So we must need to automation. So what we will do, we have thermal images, then we train our network, and then we separate the background, and you can see the canopy area or leaf area, and then we can separate the temperature range or pixel area, how much pixel area, so you can do. So here is the example. Thermal image you have, then separation of the background, and then you can separate temperature range and then area. And on the basis of that, we can like use control the watering operation, different kinds of things. So this is patented by me, this technology. So we are now doing some experiments to improve the efficiency of this system. Then one more thing, I told you that we use drone for cabbage or lettuce. So why we need this? We can measure the chlorophyll content of the leaves, the leaf healthy condition, the leaf growth. So the problem is that background. Here you can see the lettuce green, also background also green. So if you just use this image and if you convert to chlorophyll contest processing, and we can see that with noise, lot of noise, and which is the letters and which is the background is difficult. So what we can do? We can separate the background or delete the background. We can create new image, and then we can only predict the letters, the target area. In this case, the letters, and then we can predict the spread value, or this the chlorophyll content of the leaves. So around 40, 30, 50 is comfortable, is a good condition. The less or more is bad. If it's a less, then you don't you have lack of water or fertilizer. If it has more, then it's not consumable because you have over fertilizer and or other things. So here is the cabbage also. So we can separate the background and then predict the spread value of the leaves. So I think that I finished my lecture, and thank you for your patience. I think that I already finished in time, maybe a little faster or later, I don't know. I did not check it. But uh, thank you very much for your patience, and I hope you will have a lot of questions. I will try to answer all of these questions. So,
Yeah, okay. Thank you very much for Associate Professor Dr. Parvez for a very interesting topic about the AI and its application, especially for agriculture. Yeah, it's really on time. Yeah, thank you very much. Now we will continue our session with the discussion. I will give opportunity for the first the three questions, both for online and also for on-site participant. Maybe first I would like to give the chance for the online participant. You can raise your hand also, or you can write in the chat box. Now, I think, yeah, we have the first question, first raise hand from Fania Yuliana. Okay, for Fania, time is yours.
okay.
Hello, I'm Fania from Indonesia, and I want to ask about the one is like apa convolution image that's use filters. I a little bit confused about the technical of the convolution, like the technical of how it is going to filters pixels from image like that. Thank you.
Okay. So it's very simple. You know that in our case, every day we have when you like in the past we have like professional camera. Yes, you take the image and then we process the image manually to make it more beautiful, more clear, huh? More like if dark we make it like bright or something. So in this case there is some filter we call it. We employ the filter, and then this filter multiply the pixel. If you know the pixel of the image, what is this, then you can understand that if multiplying the pixel, and then we can get the output. The value is the change, and it will be dark, maybe more brighter or something. This process is convolution. I mean, the filter when you add overall image is the convolution, because it's there is a, like, how can I say, if your image size here you can see the 6 into 6, this means that 6 pixel into 6 pixel, the image size. The filter size is 3 pixel into 3 pixel. So height and width. So if you 3 into 3, like this, if you multiply, you will get it 3. This is matrix calculation. So if you know how matrix calculation used, then you can get this output. In this moment, I don't have this, but you can, if you are interested, maybe I can show later, give you the link or something, or you can get, you can see the in the link. There is a link. You can click. You can later check how it's the calculation is done. So you can understand how the calculation is going. So like image is moving from left to right. Okay, the filter is moving over the image from left to right, and each time is multiplication with that area, and the new data created. This one. So move and new data is created. New feature. So down is also, and no, like this. Then after, if you finish all this movement from top to bottom, then you have whole image. So in that case, you can see the original pixel is 6.6, but in this case, it's reduced the size 4 into 4. This is the new image. So when you employ the filter, you can create same size, you can create smaller size, you can create bigger size, but there is different technique. But in this case, I just only show you in general which we are using in convolution artificial intelligence. We are not in this moment is downsampling. It means we're decreasing the image size. So from 6 to 4, the new image is 4 into 4. So after that, if you add more, again filter, the size maybe will be more reduced. So this is the way how convolution is working. So another thing is that let's show you the, where is my algorithm network? I forget. Okay. So here you can see that you can say that or maybe it's in the input we use the image and we put the filter. Then image size is reducing. So again we use the new image, then filter. The image size is reducing. Then it's become 1 pixel. So if you have image size like 240 into 240 pixel size, then it will become 1 pixel or 2 pixel. So we're reducing the image size and new filter we enter. And then every time it create new images, and neural network is memorize that this image for fruits, this image for human, this image for others. But this is another time we need, if you want to explain only this area, I need one more lecture, only convolution neural network. But this is only concluding. I try to show you that downsampling we use, and then we predict the pixel on the basis of the.
Oh,
So if you have time, you can search internet and you can show my publication. There is a lot of explanation how we calculate how convolution network is done. So that will be more helpful for you to understand.
okay, thank you, sir.
Okay, thank you for Fania Yuliana for the question, and also Prof. Parvez for the answer. Now, I think for the online, we have one question from Tan Yuxian in the chat box. Good morning, Doctor. Thanks for the insightful lecture. I have a question regarding the presentation topic. I would like to ask, since these technologies are used in agriculture and in developing countries such as Malaysia and Indonesia, the farming system still built by small-scale farmers. How should the small-scale farmers learn to use this technology, and how should they integrate them into their farm, since this technology require high initial costing?
Okay. Thank you for your question. Actually, same thing also in Japan. Not very big farmer. But yes, there are some very big farmers, but it's maybe 1% or 2%, but 98% is small. So, you know that artificial intelligence is require a lot of investment initially. You need data, you need continuous update, you need like service and other things. So we mostly feel that it is possible for small scale farmer like subscription based. So they don't need any hardware. They just need to take the picture and send, and we just reply. We just send them the answer. I mean, we have like online linkage with the server. They send the server and get the output. Mm. This is the one of the option. So it means that you reduce the cost, but this also problem with the network. So like in Japan, they have very good network, but like Indonesia or other mountain area too far from city, there is the network problem also. Huh? So in that case, we prefer like low cost device. It is in this moment we are working with like Raspberry Pi or something very cheap device, so it reduce the cost. Hmm. So the in that case farmers can use this device very cheap. So this is like business plan. It's not matter how can say how it can cost, but it is like different types of business plan. How your country will subsidize, how your farmers will accept, and where you want to employ. But in Japan, we need a replacement of human. There is no way because the population is decreasing. But in Japan, Indonesia or others, there's no problem with the population. You have the problem with the quality. You need to ensure the quality, you need to ensure the accuracy. Uh, in that case, maybe not of this application is compatible for your country. So we need to develop for your country oriented some application or something. In this moment, I am also doing some kinds of things, for Indonesia, collaborative work like for crop insurance, other things to reduce human dependence, the human error during justification, the crop judgment, the yield quantity or others. So the insurance company can confident the quality of the judgment. So different approach in different country, I think.
Yeah. Okay. Yeah. Thanks for the clear explanation. Okay. Now I will give opportunity for the on-site participation. Please raise your hand. Yeah, you can switch on the microphone.
Hi, thank you for the class. And I'm Ken from Japan. So can I ask one question?
Yes, yes.
Yes. Um, so can you distinguish with the biting area by using AI camera like growing, blooming, and harvesting and bite it like that?
Biting, yes. You
Yes,
want the hachi ga kamanatara ne, biting, yes, yes.
yes. So my question is, you can find biting area or not?
Yes, yes, of course, we can do it in the plant factory because in the plant factory cultivation system, we have limited condition. How can say, we manipulated the plant in such condition that it cannot, how can say, it's different than outside environment in the plant factory. So the flower is very visible, and you can easily monitoring the plant factory, the biting condition. Of
Okay,
course,
thanks.
there is some occlusion or something, but this is general problem. There is no way, but it is possible.
Thank you.
Thank.
Okay. Thank you. Now I will open the second session for the question. I will give 3 opportunities. Maybe first for the on-site participants. Please raise your hand. Yeah, and so maybe also for online participants, if you have any question, please feel free to raise hand or writing your question in the chat box. Yeah, Dr. Parvez, it is very interesting. Maybe we are waiting for the question. I also have yes question for you because it is very interesting, especially for the crop monitoring system. I would like to ask you, how about do you have any experience for the monitoring system in the open field?
Yes, we duplicate these things. Now, actually, this time I cannot show you. Maybe next next year presentation, I will demonstrate you a new mechanism, new system because we are now this year I submitted the paper publication and there is a patent issue, so I cannot share all of these things. So I cannot. But next year, just I want to tell you that we are not only tomato now. We are doing with how can I say grape, mandarin, the orange, I mean mandarin, different kinds of fruits tree, and this is mostly outside. So the technology which we develop inside the plant factory and greenhouse, we are now disseminate to outside because it's still 90, 80, 85% maybe I can say in Japan farmers open field. Not everyone has the greenhouse or plant factory. Yes, it's very expensive. So how we focus. And then also I told you many of my recent work is involved with Indonesia. I am doing some joint research. So Indonesia is open field. So we are now use this method to transfer technology to the Indonesian condition for the Indonesian.
Okay. In your opinion, what is main challenges for the open field, especially in Indonesia?
I cannot. Is it okay?
Yeah. Okay. Any other question for on-site and online participants? Yeah, maybe we still have time left, but yeah, I think it is very insightful discussion about the AI and its application in agro industry. Before I close the discussion, maybe like from the committee, they will give a certificate online for you and
The camera is mute maybe.
oh,
Camera, the microphone is mute maybe. I don't know.
okay. Can you oh ada yang nanya. Okay. Sorry, we have one
Siti
Siti
Jualia.
Jualia. Yes. Siti Jualia, time
Okay.
is yours, please.
Yeah, thank you for Mr. Parvez and Miss Rizky. My name is Siti Jualia. I'm from Indonesian. So I wanna ask about the system AI. When I see the system AI is like for grape and then strawberry and the other vegetables or fruits. So if you create a system like the one described, but the fruit is growing in the ground, will it be detected through the leaves above the ground or not? How could be the system can detect that, like the camera RGB in the ground, or just detect the detection of the leaf above the ground or not, like that? Thank you.
Okay, Dr. Parvez, the question is clear. Hello, Dr. Parvez. Uh, Dr. Parvez, could you hear me?
Can you hear me?
Yeah, yes, I can hear you. How about you?
I cannot hear you.
Oh,
There is no voice from sound from your that side.
Sorry.
okay, wait a moment.
Just wait a minute. I try.
So maybe for Siti Jualia, can you write your question in the chat box? Yeah, so then Dr. Parvez can
Just
read.
wait a minute. I try to change.
Okay.
Hmm. Hmm.
We have one
Oh,
question
yeah.
in the chat box. Yeah.
I can hear you.
Okay.
Yes, okay.
Yeah.
Uh,
Yeah. There is one question from
yes.
Siti Jualia about if you create a system like the one described, but the fruit is growing in the ground, will it be detected through the leaves above the ground or not?
No, if it is any obstacle, because it depend on your camera. If camera see, you can detect. If camera not cannot see, you cannot do it. So this is depend on the how you can. If there is an obstacle, then you cannot see it. Yes. If you cannot see it, then you cannot tell anything what is there. This is the thing. So in that case, different way. You need to X-ray or something to see the obstacle. But in general, no one in this world can do this. Very expensive because it cannot see it. I mean, your camera.
Okay. Thank you very much. Because now we almost reached the time, so I think I would like to give a short summary about the lecture from Associate Professor Dr. Parvez Islam. He is exploring about how artificial intelligence can transform the agri-food industry. In particular, for facing the global challenges such as the rising temperature, declining grain production, and growing population. In particular, environmental stress, for example, the extreme weather like temperatures increasing will disturb the plant metabolism and will affect the crop production. And therefore, like the next generation agriculture should be focused on how the plant growing can combat these challenges. For example, using the plant factories or smart greenhouses. And then for the application like AI application, it can detect like or monitoring the crop growing, especially inside the greenhouse or plant factory. For example, for the disease classification, for worker stress assessment in the greenhouse, for flower, how to say, like elimination, and also the product grading. And now I would like to say thank you for Dr. Parvez for your valuable time and insight about the course. I wish you have a good day, and we can meet you maybe next time in the presence. For example, you can visit us in Universitas Gadjah Mada. Okay, now we have the appreciation from the committee. We will give you an online certificate.
Okay, thank you so much to Associate Professor Dr. Parvez Islam for being an insightful lecture about artificial intelligence in smart greenhouses, enhancing crop monitoring and environmental control. We would like to give the appreciation certificate that will given symbolized by our moderator.
Thank you very much. Thank you for your appreciation. I hope I will able. I have a plan to visit on October. I will visit mid-October UGM. Yes. So 15 or 16 maybe October. I will stay there. So
Okay,
hope
thank
to
you.
see some
Yeah.
of you.
Looking forward to see you in person in the next
Thank you.
meeting. Thank you very much. We
Thank you.
give applause to Dr. Parvez.
And also, we would like to thank Dr. Rizky Maftuha, who led the discussion before, and the certificate of appreciation will be given by the chairman of the 7th Summer Course Program, Dr. Fiameta Ayu Purwandari. with the session of appreciation certificate already implemented, then the second material of the summer course has ended. For operators, you may stop the recording.